A press can be programmed to reach a specific force, position, speed, pressure, or temperature. But requesting a value doesn't guarantee the press is actually achieving it. Closed-loop process control closes that gap by measuring what is happening and correcting the process in real time.
So very simply, closed-loop process control is a process where you ask for a specific requirement, then you check it to see if you're getting that and make a correction to get to that point. A simple example would be your stove at home. You set it at 350 degrees and the stove will heat to that point and shut off, but turn on occasionally in order to maintain that 350 degrees.
The key difference is feedback. An open-loop system sends a command but doesn't use the result to adjust that command.
The closed-loop control is going to look for a parameter, make changes to get to that, whereas in open loop, we just send out the signal and we don't make a correction. What we get is what we get.
On a press, sensors provide that feedback throughout the operating cycle.
Press can monitor and control almost every parameter that we ask for, but the most common would be pressure or force, speed, or temperature.
The control system continuously compares the measured value with the target. The difference between the two is called the error.
The system calculates an error. That error can be a positive or a negative error. So when we're moving away from the target, the system decides whether it's positive or negative and then makes a change in the opposite direction. For example, if we were monitoring speed and we were going too slow, that would be a negative error. So it would make a correction in the positive direction in order to increase our speed to match the target.
That automatic correction becomes especially valuable when operating conditions aren't perfectly consistent.
Yeah, closed-loop process is really used when you have a system that is not consistent all the time. So if you have product that goes into the press at different temperatures, or maybe you've added some lubrication to it that creates a slightly different motion every time, the closed-loop motion control will compensate for that.
The goal isn't simply to make the press more precise. It is to keep the process and the parts it produces more consistent.
By having closed-loop control, that allows you to hit your tonnage or your end point or your speeds more accurately and ignore those other variables.
Closed-loop control can only correct the variables it has been designed and programmed to control. It cannot determine the correct process parameters on its own, and it can't fix every underlying production problem.
Loop control corrects up to the point that you've asked it to correct to. So if there's a process issue that goes beyond what you've asked for, the closed loop control won't make corrections for that. So if you're trying to make a product at 1,000 tons and that product's not being made at 1,000 tons and it needs, say, 1,100 tons, the machine won't know that it has to go to the 1,100 tons. So you've limited it. It also won't make corrections for bad product or tooling. So if you're looking for a product to hit a specific thickness, but your tooling is not level or even, then your closed loop control won't be able to compensate for that sort of thing.
Not every press application requires this level of control. The decision depends on what determines the final part, the tooling, the press motion, or a combination of both.
So closed loop control is a more expensive process. It is more accurate, but using it requires a lot more tuning and a lot more control. So your expenses to run the machine are going to be a little higher. Your expenses to set up the machine are going to be a little higher, but in the end, it gives you a better product.
Closed-loop control isn't automatically necessary for every press operation. The real question is whether the process depends on the press maintaining a specific target despite changes in the material, tooling, temperature, or other operating conditions. When it does, real-time feedback can be the difference between simply commanding a process and consistently controlling it.